Chapter 1, Section 6 is Other Types of Equations. So here we're going to see equations where there are higher powers other than 2. And we'll also see radical equations, which are really equations with rational exponents. So a linear equation in x is an equation with a degree of 1. And that's because the exponent on the x here is a 1. So the degree of a linear is 1. A quadratic equation is an equation with a degree of 2. Because remember, we take a look at all of the terms in the equation and we look for the highest exponent, and that's 2. Polynomial equations are of degree greater than 2. So you'll see exponents that are bigger than 2. Okay, the first two examples we are going to solve by factoring. Thus the reason why we did all the work with factoring. So the first example is 4x to the power of 4 equals 12x squared. Now we are going to factor, and to factor you must have everything on one side set equal to 0, because remember, we're going to use ZPP, the zero product principle. You can't use that principle unless everything is set equal to 0. So I'm going to move 12x squared over here with the 4x to the 4th by subtraction. 4x to the 4th subtract 12x squared equals 0. All right, what type of factoring is this? Many times students lose sight of this type of factoring. This is GCF. Okay, so first thing we did here was put it in general form. Next thing we do is we're going to factor, and this is GCF factoring. So what comes out? 4 divides 4 and 12, and we can take out an x squared. So my GCF is 4x squared. And remember, factor means divide, so I'm going to divide both of those terms by 4x squared, and I'm going to be left with x squared, subtract 3, equals 0. Okay, now I'm going to use ZPP, zero product principle. If the product of two factors is equal to 0, then one of those factors has to be equal to 0. When I solve the first mini equation, I divide by 4, I'll still get 0. When I take the square root, I'm still going to get 0. So x equals 0. When I take the 3 over, it becomes positive, and when I remove the squaring by square root, x equals positive or negative square root of 3. Now remember, the plus or minus has to be out front, not inside the radical. Okay, so now I'm going to check my answers. In the original, 4x to the 4th equals 12 x to the 2nd. I have 3 checks. I have 3 potential solutions, so I have 3 checks. So I'm just going to set up the template, and then I'm going to substitute into it afterwards. All right, so my potential solutions are 0, negative square root of 3, and positive square root of 3. Okay, so for the first check, Raising 0 to the power of 4 and multiplying by 4 still gives me a 0. And I will get a 0 over here on the right. So that works. When I take a negative to an even power, it's going to be positive. This thing is root 3 times itself 4 times, or 9 times 4, 36. Negative to an even power is positive. Root 3 times itself is 3, times 12 is 36. It also works. You'll get the same result here. The only thing different between this check and this check is this was negative, but it went positive anyway. And so you will end up with 36 equals 36. Again, this number was 9, right? Because this is root 3 squared times root 3 squared, and root 3 squared is 3. So if you have root 3 squared 2 times, that's 3 2 times, and 3 times 3 is 9, times 4 is 36. In case you were wondering how I jumped to that so quickly. Because all of the values do check, I now put my answer in set notation. The solutions for this equation are negative root 3, 0, and positive root 3. Typically, I will put my answers in increasing order. It's not necessary as long as all the answers are there. Just make sure you're not doing this plus or minus inside the set notation. So if you have any questions, post a comment on the discussion or ask in class. Okay, next example. 2 times x to the power of 3 plus 3x squared equals 8x plus 12. They did tell me to factor, so I have to put it in general form. I'm going to move the 8x and the 12 over to the left. 2x cubed plus 3x squared, subtract 8x, subtract 12, equals 0. That's my general form. When you have 4 or more items, you have to factor by grouping. The first two have something in common, so do the second two. So I'm not going to change the order here. I'm just going to show that I'm going to group 2x cubed and 3x squared. Remember, I said always put plus in the middle so that you remember to factor out that leading negative and change the sign of both terms. That's the rationale between that. So this is grouping. Now I'm ready to take a GCF out of here. Well, the only thing that can come out is an x squared. Okay, so again, we have x squared in common. So I'm going to pull that out. I'm going to factor it out. And factor means divide, so divide both of these, right? Anytime you factor by grouping, you are looking to pull out a GCF. So this then is going to be 2x plus 3. And here, remember, you must factor out all leading negatives, so you take the negative out, and 8 and 12, the only factor they have in common is 4. So I'm going to pull out a negative 4, and I'm going to divide both of those by negative 4 and get 2x plus 3. And I like what I'm seeing because these two things match. That's a GCF of this term and this term. So I'm going to factor out the 2x plus 3. Multiplied with the x squared, subtract 4. This is dots. I can factor that more. So I get 2x plus 3. Now I'm going to factor dots as x plus 2 with x minus 2. And now I can use ZPP. Okay, so this whole thing was factor. And now I'm ready to use zero product principle. So here, remember, change the sign of this and divide by what's in front of x. So x is negative 3 over 2. Here, x is negative 2. Here, x is positive 2. Okay, now I'm going to set up for my checking, which, you know, the setup doesn't, I mean, it takes a few seconds to write them out. 2x cubed plus 3x squared. I do like to write the template and substitute in. I know I've told you that before, but I think it's easy because I look and I see I have 3 potential solutions to check, and so I can just copy the top template and don't have to do much thinking. It's kind of just like copy paste without copying and pasting with a computer. Okay. First potential solution is negative 3 over 2. This one I might choose to use the calculator. You have to type it in correctly though. Now the next one is negative 2. And the next one is positive 2. Now you have to be careful with this. Like the last example, the last 2 checks, you ended up with the same value on each side. This one you won't, because a negative cubed is still a negative, and a positive cubed is a positive. So you're going to get different answers for the checks here. Let's see, I guess I will take the time to at least do the top one on the calculator. So I'm going to turn it on, hit clear. 2, I need a parenthesis. Negative 3 divided by 2, close it, raise it to the power of 3, plus 3, parenthesis, negative 3 divided by 2, close it, square it, hit equals, oh, I got 0. Nice. Other side, 8, parenthesis, negative 3 divided by 2, close it, plus 12. That also equals 0. So it works. 0 equals 0. Cube of 2, you get 8. It's negative times 2 is 16. That's negative 16. Over here, square a negative 2, you get 4. 4 times 3 is 12, so that's plus 12. I get negative 4. This is negative 16 plus 12. Again, that's negative 4. All right, this time, cube of 2, you get 8 times 2 is 16. This is 4 times 3 is 12. 16 plus 12 is 28. And over here, you're going to get the same 16 plus 12, 28. So all of these checks work. Now I can conclude that the solution to this equation is negative 2, negative 3 over 2, and positive 2. Okay, so if you have any questions, post a comment or ask me in class. All right, side 2, we're going to talk about the radical equations. You should have done radical equations in Algebra 2. So, again, this part here is equations involving radicals. We're going to solve and check. First example is the square root of 6x plus 7, subtract x equals 2. Now, you need to get a game plan. The rule is that you need to isolate the radical because you want to get rid of the square root symbol. And remember, with solving equations, you always do opposite operations. So, I'm going to get that radical by itself, and the opposite operation of square rooting is squaring. So isolate, isolate, isolate first so that you can remove how this is, I guess if you want to say, it's kind of grouped in there underneath that radical. So I'm going to write the square root of 6x plus 7 equals, when I add x, it's going to be positive over here, x plus 2. We're now going to square both sides, and it is sides. You're going to get a quantity on the right side, so you have to be careful with that. And I've seen some students squaring the x and squaring the 2. You can't do that. Remember when you square a binomial, it's square it, multiply them, and double in the middle. Okay, the left side is 6x plus 7. The right side is square the x squared. Square the 2 plus 4. First times second, 2x doubled is 4x. Okay, so squaring a binomial always gives a trinomial. Now I have to combine like terms and get everything on one side. So I'm going to move this and this over here. I'm going to move this and this, make that be a 0, because I need general form. I want to see if this will factor. So I get x squared. 4x subtract 6x is negative 2x. 4 subtract 7 is negative 3. All right, when I factor this, multiplies to 3, subtracts to 2. Well, that's 3 and 1. So that's going to be x, 1, x, 3. I'm just switching sides. I like my 0 on the right. The signs are different. The larger product is negative. Well, 3x would be bigger than 1x, so that's got to be negative and that's positive. Okay, so what did I do here? Isolate. General form. And this step was factor. Now, sometimes these won't factor. If they don't factor, you must use complete the square. Okay, so be cognizant of that. Now I'm going to use ZPP to get my potential solutions. X equals negative 1, x equals positive 3. It is so essential that you check these, because if you end up with a value of x that causes you to have a negative under your radical, then that's not real. Hence the reason why I make you check all of these. So, set up 2 checks. Over here, I've got the square root of 6, parenthesis for x, plus 7, subtract x, does that equal 2? I'll set up the second one here. Square root 6x plus 7, subtract x, does that equal 2? I'm going to put a negative 1 in here and here. I'm going to put a 3 here and here. This is negative 6 plus 7, which is 1, and the square root of 1 is 1. This is positive 1, right? The opposite of negative 1 is positive 1. So 1 plus 1 is 2. It works. This is 18 plus 7 inside the radical. 18 and 7 is 25. The square root of it is 5. 5 subtract 3 is 2. It works. They don't always work, and sometimes only one will work. But since they both work, I now can conclude that my solutions to this equation are when x is negative 1 and positive 3. One more with a double radical. Square root of x plus 5. Subtract square root x subtract 3 equals 2. Now you still do have to isolate, and you're going to end up with radical on the other side as well, but that's okay because then you're going to isolate again. Okay, so this one's just recursive. Okay, so because this is negative, I'm going to move that to the other side. So in my first isolation step, I got radical x plus 5 equals square root of x minus 3 plus 2. I like to write this a little bit farther away so that I don't mistake this 2 being inside the radical. Remember, I have to do opposite operations to get rid of the square root symbol on the one that I chose to isolate. And you do have to square sides. If you have a quantity over here, then it is what it is. On the left side, you get x plus 5. On the right side, when I square this, I get x minus 3. When I square a 2, I get 4. the middle term is you have to multiply them and double it. This term, add or multiply with this term, right? That's going to give me 2 square roots of x minus 3. Doubled is 4 of those. So plus 4 square roots of x minus 3. So I'm not done yet. This one's a little bit longer. I do have to combine like terms though. I have a linear term and I have a constant and another constant over here. So I'm going to do x, negative 3 plus 4 is 1, plus 4 of these. And because I want to get this radical by itself, I'm going to move these two over here. I'm going to cross that out, cross that out. Now, x subtract x is no more x. And then 5 subtract 1 is 4. Now, you could divide both sides here by 4 and get a 1 here. But I'm not going to do that because I want you to see what happens when this coefficient, or the number in front of the radical, does not divide this. If it does not divide it, then you need to square both sides at this step. Again, obviously, to make things easier for this problem, I would divide by the 4. And I'll show you that over here. I'll do an OR and see that you get the same answer. All right, 4 squared is 16. Now remember, when you have a product to a power, you have to square this and this. Okay, so this is going to equal 16 times the quantity x minus 3. Now you can divide these out, right? And that's going to be a 1 equals x minus 3. Okay, so more often than not, the reason I'm showing it this way is because students forget to square this one. And I don't want you to forget to square that one. Now, when I add the 3 over, I'm going to get x is 4. Okay, so over here, I could have done, I'm just going to recopy it, 4 equals 4 times the square root of x minus 3. I could have divided by 4 here first, and then squared. Squaring 1, you still get 1. Squaring this, you still get x minus 3. And you would still get the answer of x is 4. Okay, if you did not square that here, you know, if you had a 4 here, you would divide by 4 and you'd have a 4 here, and then your answer would be 7. Okay, so just remember you have to square that 4. Alright, I have to check these. Yay for me, I only have one solution, so I only have one check. And remember, you always check in the original. So I've got the square root of x plus 5, subtract the square root of x, subtract 3, equaling 2. I'm going to substitute my supposed solution of 4. 4 and 5 is 9. The square root of 9 is 3. This is a 3. 4 subtract 3 is 1. The square root of 1 is 1. So this becomes 3 subtract 1 is 2. It does check. And so I conclude that my solution to this equation is when x is 4. If you have any questions, please post on the homework discussion or ask me in class. Have a great day.